In this video, we will continue to talk about parallel lines and congruent angles that are associated with these parallel lines. So one thing that this section starts off talking about is something called the parallel postulate. So recall that a postulate is something that can't be proved, we just kind of assume it. And the parallel postulate says that through a point, not on a line, there is exactly one parallel to the given line. So if we look at the diagram below, we have point A, and point A is not on that line. So basically what this postulate is saying is that there is only one line that I can draw through point A that will be parallel to the line given. And that will work with any point that is not on a line. There's only one line I can draw through point A that is going to be parallel to this given line. And that's what the parallel postulate says. Now recall that in the last section we talked about some different theorems that have to do with parallel lines. So in this section you're going to be working with the converse of each of those theorems. So we're going to be working with the reverse. So in this section, you're going to be given that two lines are parallel, and then you're going to be trying to prove that some of those different angles are congruent, as opposed to in the last section when we proved that lines were parallel. So now we're going to be given that lines are parallel and just use the reverse of each of those. So we're just going to go ahead and copy down the converse of each of those from the last section. The first one said if two parallel lines are cut by a transversal, then alternate exterior angles are congruent. The next one starts off the same way. If two parallel lines are cut by a transversal, so instead of rewriting it, I'm just going to use little quotation marks, then corresponding angles are congruent. And same goes for alternate interior angles. If two parallel lines are cut by a transversal, then alternate interior angles are congruent. The fourth theorem says the same thing. If two parallel lines are cut by a transversal, then interior on the same side of the transversal are supplementary. Theorem 5 says if two parallel lines are cut by a transversal, then exterior on the same side are supplementary. The last one says, in a plane, if a line is perpendicular to one of two parallel lines, then it is perpendicular to the other. So when would you use the converse of the parallel line theorems? Anytime you are given that two lines are parallel in your givens. If that is given, then you should be looking for angles, trying to prove either that they are congruent or supplementary or perpendicular. So that's when you're going to use these converse of the theorems. And you'll see an example in the next video. The next theorem has to do with the transitive property for parallel lines. This works very similar to just the transitive property in general. So normally we use the transitive property when we have two or more sets of angles or segments congruent to each other. Now, the transitive property for parallel lines is usually when you have two sets of lines parallel, two or more sets of lines parallel. So if you look at this example, we're given that A is parallel to B. So line A is parallel to B, and we know that line B is parallel to line C. So what conclusion can we make? We could make the conclusion that line A must be parallel to line C by the transitive property for parallel lines. So that's when you would use this theorem. And then finally, the last theorem in this section has to do with, again, parallel lines. And it says, if two parallel lines are cut by a transversal, then any pair of angles formed is either congruent or supplementary. So looking at the diagram below, we're given that the two lines are parallel and there's a transversal cutting them. We know this angle at the top is 60 degrees, so now you should be able to fill in the remaining angles in this diagram. So pause the video, see if you can fill in the remaining angles, and then press play to check your answers. Okay, so check your answers. Notice that any pair of angles in this diagram is either congruent or supplementary. So that's kind of where that theorem comes from. So I know there were a lot of theorems in this section, so we're going to practice using these over and over. Move on to the next video to try some examples